Hello, today we're going to talk about just an introduction to the terminology associated with solutions, and I'm going to give you an overview of chromatography prior to our lab. So a solution, you should have learned about these back in honors chemistry, but a solution is a mixture of a solvent. Often that solvent is water, but it doesn't have to be, and a solute. That is the thing that you are dissolving in the solvent, okay? And the combination of those two things together is a solution. And one of the key characteristics of a solution is that everything dissolves to the point where the particles are all single molecules, okay, or atoms, but in this case molecules because we're talking about sugar, right? So it will look like the sugar disappeared essentially, right? But it is still there in the water, and all of the sugar water molecules are now surrounded completely by water molecules. Okay, so we've got solution is that mixture, a solvent is what we're dissolving everything in, and the solute is what we're dissolving, all right? An aqueous solution, which is what we usually deal with in chemistry, at least in this chemistry. When you get to organic, you have other solvents often, but usually we deal with an aqueous solution. That just means that our solvent is water, all right? And that when we write our balanced equations and we have the little AQ at the end, that's what that means. It's something that's dissolved in water. So solubility is a measure of how much of a solute will dissolve in a solvent under given conditions. So the solubility is often dependent on temperature and on pressure. Okay, but you can make estimates about how things are going to dissolve or not dissolve based on the properties of both the solute and the solvent. So we have a phrase in chemistry that's like dissolves like, and it means that things that have similar polarities tend to dissolve one another. So water is polar, so it will dissolve other things that are polar, like sugar, and it will also dissolve ions because they have charges that can interact with the polar water molecules. Okay, whereas water does not readily dissolve things that are non-polar. Okay. And similarly, if we want to dissolve something that's nonpolar, we would want to pick a nonpolar solvent because water is not the best option for that. Okay, so we can use this this principle that like dissolves like to separate things using chromatography paper or filter paper. Okay, so the example that's shown here is a spot of ink. All right, it is spotted on the paper. All right, and then we have a solvent. Okay, and we put the whole thing in a beaker, all right? And so because of capillary action, that water, or whatever the solvent is going to move up the paper over time, okay? And the ink will move if it dissolves in the solvent, and it will not move if it doesn't dissolve in the solvent. So it's really a balance between whether the ink would prefer to interact with the paper or with the solvent. Okay, so if we're using a polar solvent, things that move faster, like this yellow spot up here, would be more polar. And if we're using a non-polar solvent, then we would assume that the things up here are going to be more non-polar because they, the faster they move, the more they interact with the solvent. Okay, and we can quantify this movement with an RF value. So that's basically how far did the solvent move versus how far our pigment or our dye or whatever it is we're doing chromatography on, how far did it move? Okay, so in the examples I'm showing here, we're using something that we can see with our eyes, although scientists often use other kinds of compounds, so you need to have some way to visualize them, but maybe they just absorb UV light, and so you would measure your distance of your different components under UV light so that you could see the spots, all right? So we are going to do this in the lab this week, and you'll be able to see how we can separate things based on whether they are polar or non-polar.